Hello guys, this is Anpichan and welcome to my mathematics class, especially calculus class. Today I've taken limit at infinity. Before that I have taught limit of algebraic functions, right? How to evaluation of the limit of algebraic functions. So today I'm going to teach you or limit at infinity. How to find out the limit of function, especially algebraic functions today as x tends to infinity. Let's see the limit at infinity definition. I've written here a function f of x is said to tend to L is number, constant number as x tends to infinity if f of x can be made close to L when x is greater than any pre-assigned number, however large. It doesn't matter, okay? Same as we have defined already, definition of the limit of function. Here also the same things are written here. Only okay, pre-assigned number, however large. Okay, it doesn't matter here large. If you assign 1 lakh, then okay more than that also x. Okay, if you assign any pre-assigned number, x is greater than that. So meaning okay here x tends to infinity, right? Limit of f of x tends to infinity. It comes equal to your constant number L, right? So let's see how to find out. I think okay, if you read this one and same thing here also I've written today as I wrote in the last videos, definition of the limit of function, right? So there is nothing. Firstly, let me clear, okay, one thing before doing questions limit at infinity. Let me explain you this one. Uh, when here, right? When x tends to infinity, then 1 upon x tends to 0 or any other here, okay, real number, you can say a real number, n upon x tends to 0, okay, or where n belongs to, let's suppose, okay, real number. If we take here 0 and x tends to except okay 0, all right. uh, Now see, let me uh, show you how it comes. Okay, 1x tends to 0, 1 upon x, 2 upon x, 3 upon x, 5 upon x, any other, okay, any real number, negative, it doesn't matter. Minus 2 upon x tends to 0, and minus 3 upon x tends to 0, right? And 5 upon x also tends to 0. Yeah, 1000 upon x also tends to 0, right? When x tends to 0, then these all okay, values okay tends to 0, tends to 0, okay. And see here, if we have suppose think, okay, if we write okay 0 upon x, so this is already 0 and then no problem, except okay 0 here, any real number, okay, except 0 you can say, right? If there is a 0 upon x, okay, so straight away okay 0 we will write, okay, okay. So so there is no question to write down as I have written here in this form. So real number, okay, here numerator is an real number except your 0, you can see here, right? If we have in this form here any real number except 0, okay, your numerator belongs to real number, right? Okay, except okay 0, then we can say your x tends to means infinity, then any okay real number except 0 upon here, suppose any real number, okay, and any real number I have supposed here, and okay, any real number, then upon infinity is equal to 0, right? Now see everybody, so I'm going to explain, okay, suppose as x tends to infinity, 1 upon x tends to 0, why? 2 upon x tends to 0, why? 3 upon x tends to 0, why? So see everybody here, x Here let's suppose value of 1 upon x. Here let's start by 10, 0 0.1, 100, 0.01. So I will do mistake in calculation. So combine. So 1 upon 0.001, I think 1 upon 1000, and so on. Okay, right? So if you take here 1 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 and so on. Let's suppose, okay, then you will get here 0 0.0000000000000 dot 1. Yes. Here also if you take with 0 0 0 0 and dot dot and here 1 dot means 0.0000000 dot 1 0.0000000 at last, okay, you will get 1, right? Your last digit, okay, will be your 1. Okay, 0 0.0, which is not exactly 0 but approaches 0 and which is almost near to 0. All right. So let's suppose, okay, here, so similar, and here if, okay, 0 0, if you assign any, okay, number, okay, and however large, okay, and then, okay, here, okay, x tends to infinity, 1 upon x tends to 0.000. If you, okay, when x is greater than any pre-assigned number, if you assign any number x is greater than that also, then 1 upon x tends to 0. Using this concept today we will evaluate the limit of algebraic function at infinity. Okay, so let's see. Look at here, everybody. Now I am going to evaluate solution. Very simple questions I have taken today. One number. Solution here. Limit x as x tends to infinity. X plus a minus root x under root x. Last time we met with 0 upon 0 in determinant form. So today you have form infinity plus a infinity minus infinity form. So if you use directly infinity, you are gonna get here infinity minus infinity, which is indeterminate form. Indeterminate form. This means, okay, as I told you already, if we get indeterminate form, we need to simplify. Let's simplify. So how to simplify? Let's multiply up and down numerator and denominator by the conjugate of numerator. By conjugate of numerator. So what is the conjugate of numerator? So minus root x into root x plus a plus root x. So root x plus a plus root x is the conjugate of numerator, and root x plus a plus root x, okay, is equal to limit x tends to infinity. Here let's simplify by using formula of a minus b a plus b. We write down here root x plus a whole square minus root x whole square, and here same, no problem, it's not creating any problem. Okay, and the limit x tends to infinity. In numerator we are going to get here x plus a minus x. In denominator we have x plus a plus root x. Now next line, x as x tends to infinity. Here a upon root x plus a plus root x. Okay, so I think you're clear about this definition. So I am expanding it from here. Okay, and moving this side is equal to, oh, okay, so once again I'm repeating the same line. I guess you might have not seen there. Okay, so once again I have repeated this line so that you can see clearly here. Okay, now this is not in indeterminate form. It's free from indeterminate form. So let's apply x tends to infinity. Upon as x tends to infinity, x plus a tends to infinity. Root of infinity is also infinity. If you multiply any real number except 0, you are going to get infinity. Root of infinity is also, we write down infinity. Infinity plus also infinity. Infinity plus infinity is also infinity. You divide by any real number except 0, and that is also going to come infinity, right? So infinity upon 0. So we can see infinity into infinity, all right? So infinity, if you multiply by any real number except 0, so if you multiply the infinity, that is also infinity. Infinity, so root infinity plus a infinity. If you add any real number with infinity, that is also again infinity. It is also infinity. Here root infinity, as x tends to infinity, root x tends to infinity. So infinity plus infinity is not in indeterminate form. This is the defined thing. Infinity, okay, plus infinity. If you add, okay, suppose this is if you add, okay, here also. So use pile of stones. Use pile of stones. Then again you gonna get, okay, by use pile of stones, okay, like this, right? So this is the depending infinity plus infinity. Infinity we can write down, right? Not in indeterminate form, not talking meaningless form. Although, okay, infinity is not any real number. This is just, okay, symbol for right extreme thing or left extreme thing. If we talk about the number line, right? It means infinity represents the very huge, uh, large number, right? Larger than any pre-signed number, you can say, right? Upon infinity plus infinity is again infinity, right? So as I told you, a real number except 0 upon infinity is 0. As I already explained, okay, is any, so as x tends to infinity, 1 upon x tends to 0. I have explained. Similarly, so I think you couldn't see here. You can here, as I told you, as x tends to infinity, 1 upon x tends to infinity. Okay, infinity. So similarly here we can say as x tends to infinity, a upon infinity tends to 0. So 0 is the limit of function at infinity. Okay, everybody? So I think you are clear how to find, how to evaluate the limit of algebraic function at infinity. Okay. So similarly, you can do this question, same questions. So I've left for you for practice today. You can do these all questions. So only one three number I will tell you, but this is also similar type of question. All are of the same type of question. Answer. I mean to limit of all this question 0. Here also 0. Here also 0. Here also 0, here also 0. You can try yourself also remaining questions. I will tell you one more question so that you will be clear about the concept. Let's see here. Here we go. Question number 3. Question number 3. Solution. Limit as x tends to infinity, root x minus a upon x minus b. Okay. So if we start to use x tends to infinity, let's see what thing we will get here. X as x tends to infinity, x minus a tends to infinity. Root of infinity, infinity. X minus b also tends to infinity. Root of this infinity. We are going to get from infinity minus infinity. This is our indeterminate form. Now we need to simplify, okay? So as I told you, the same method we will use to simplify here. Just we will multiply up and down, I mean to numerator and denominator of the function by conjugate of the numerator. Just we can say the rationalizing numerator. Root x minus a, root x minus b, and here root x minus a plus root x minus b. Okay, I think you understood here. X minus a plus root x minus b. So I guess you are enjoying with limit as x tends to infinity. Infinity. Sorry here. Exact symbol. Exactly we have to write down. Okay, here directly I'm writing it's gonna be x minus a minus x minus b. I think you understood here we used a square minus b square formula, right? Which one formula? This one formula. A minus b into a plus b, we can write down a square minus b square. Using this formula, I have written this one here. As I told you in the first question, in x minus a plus root x minus b, limit as x tends to infinity upon x minus a minus x plus b, cancel, root x minus a plus root x minus b. Okay, I'm going to erase this. Again I'm making a arrow. I don't have so big whiteboard. Okay, no problem. It's enough to convey mathematical language from here to your brain. B minus a sorry, I beg to pardon. Here I need to write down limit x tends to infinity of b minus a. So in numerator we got constant root x minus in denominator x minus b. Okay, so in numerator we have constant, so there is no chance to come here indeterminate form. Now we can use here x tends to infinity, so b minus a, as x tends to infinity, x minus a tends to infinity, and root of infinity means infinity. Here also similarly infinity. Now as I told you, infinity plus infinity is infinity. So b minus is a real number. So it's going to be 0. So something upon infinity is equal to 0. Okay. So this is the limit of function, right, at infinity. I hope you can do the remaining questions. Only just 3 questions I have given for you for practice. You can do practice of this one, and these 2 questions are also here. Answers of this also 0, answer of this also 0, answer of this also 0. Okay. Today I've taken only very easy question, just very dead simple questions, how to find out the limit of algebraic function at infinity. In next video definitely I'm coming with little bit harder questions of same type of same type of function I will take here, but same type of limit. I mean to okay. I will come with the little bit harder questions to find the limit at infinity. So I hope you will try, and for more practice, if you are enjoying with these questions, for more practice you can go through the books of class 11, class 12, or any board you can use, right? It doesn't matter. You will get the same type of a topic either in India, either in Nepal, or in any such countries, or secondary level of on a European board or in American board. You can find out the similar type of mathematics everywhere. If you see the basic level of calculus, you're gonna get okay everywhere same type of mathematics, right? Mathematics is the same wherever you are staying. It doesn't matter. You just go through these questions, and so go through the similar type of questions from the books and try. If you don't get okay, if you get any problem, you can do comment and write down the comment in my comment box. Definitely I'll try to give the response of your each and every question. uh, Thank you for watching my video. Okay. And don't forget, at last again, I'm repeating in each and every video. If you are new one, please subscribe and stay with my channel. You are definitely going to be benefited, and you will get lots of mathematics in this channel. Okay, thank you. Have a wonderful time. Bye bye.